Our next presenter is Tobin Bradley with Mecklenburg County GIS. He's going to talk to us about the quality of life dashboard, which was essentially an online dashboard created as part of the quality of life study that was done down in the Charlotte area. So, Tobin, take it away.
Wow. I never thought I would make it to the 8:30 Friday session at this conference. I think Ann figured that out finally and assigned me to the 8:30 this presentation. Hi, I'm Tobin. I work for Mecklenburg County. I'm going to talk to you about one of my children, the Quality of Life Dashboard. The dashboard's part of the Quality of Life Study, which is a collaborative effort between UNCC and the City of Charlotte and Mecklenburg County. UNCC and City of Charlotte do all the hard work, making the data and the meta and the community outreach, and I play around with websites. So the Quality of Life Dashboard is a totally open source project from top to bottom. It's built with open source libraries using open source tools, and the whole project is released as open source code. It has been one of our most successful open source projects to date. It's been deployed in a number of places. Code for America is working on deploying it in Lexington. So it has been a lot of fun and very successful. And the exciting news is version 2 is out. It's all new, all brand new, rewritten, top to bottom. It's super awesome. You guys probably aren't doing anything this weekend, so download it and make your own dashboard and have a good time. Asterisk. We haven't released version 2 for Mecklenburg quite yet. We discovered very late in the game we had a problem related to data and calculators. It's very boring. But we haven't quite, we were supposed to be released. We missed our launch date a little bit. But version 2 is ready, so feel free to grab it. And if you launch before we do, just don't tell us. So I'm going to do something which is probably a terrible idea. I'm going to do a live demo. And as I said, this isn't launched yet, and I don't know how you might be able to figure out where our development server is so you can look at it yourself. But if you do, that's probably not my fault. So, it starts out looking something like this. It has the giant Jumbotron, which is very popular and pretty useless. So once you click on that, that'll disappear from the universe forever, and it will flash what I want you to do next. And it's really good to hear about design in the last talk, because that's something we tend to neglect sometimes in GIS. One of the biggest things people run into when they see one of our map interfaces with 100 buttons and widgets is they don't know where to start. And they're kind of paralyzed. So show them where to start when they get to your site. So the site kind of looks like this. It's you have all your data visualization stuff on top, and then a whole bunch of contextual information on the bottom. It's on the bottom because, although it's important, most people will never, ever read that. So that goes down at the bottom for the few people that will. Everybody else gets to see the data. You're looking at the data. You've got your map here, and this works the typical way you would think a map works. And it's set to just show the coral cleft. You can turn on map tiles if you want. Oh, good, the internet's still working. This is what I'm doing this at a little bit of an obtuse angle. So you have a map and a couple of visualizations. These are all tied together. So when you pick a few neighborhoods, when you hover over a neighborhood, you'll see it on the chart. You'll see it on the table beneath. Everything's interrelated together when you have things selected. This chart over here is kind of an interesting visualization. It's you notice there's no legend for the map. The legend is actually that bar chart. The quantiles are set up for the different colors in the map. The height of the bar indicates how many neighborhoods are in that particular quantile. It can be really hard when you're dealing with irregularly shaped polygons and you have a whole lot of them to really understand the distribution of your data when you're looking at a set this big. Here we can understand the distribution. The dashed line is the median. You'll see each neighborhood comes up as a dot on the chart. So you can do interesting things with that. And this is a trend chart. that'll appear when we have more than 1 year worth of data. If we go up and pick, let's see, high school diplomas, and we pick the small 2s quantiles, and you can pick those quantiles just by clicking on the chart. And you pick something that you think might be related, like household income. You'll notice those points stay together, and that indicates that those two metrics might be related to each other. If you pick a metric that probably isn't related, like 311 requests, you'll see they fan out. So those two things probably are not related to each other. So that one visualization, you get distribution of your data, legend for the map, and you can see correlations between different types of data. So that was fun. If I ever put data visualization engineer on my resume, it'll be because of this one little chart. Once you have some things selected, you make a report, it'll go off, and this report is designed to look exactly like the print preview page in Google Chrome. So I'll make a map and some things we find interesting, a zoomed in map, and each category of data will get its own page with some charts we think are kind of interesting. And again, this is set up. I've made PDF export things from the web for a long time. I've recently decided those things should die in a fire. So this is just HTML and a plain old web page. It's a lot more useful and it's a lot more fun to do. Making PDFs that's terrible. So, and of course, all the code is out on GitHub. We put a link right on the page, and it'll have extensive directions on how to get started. Well, that is the dashboard in a nutshell. It's designed to be, it's designed to be as easy to use as we can make it to be, and still, it's like the minimum viable product to show everything we wanted to show, but still make it approachable enough for folks to use. All right. Imagine that's me, but I have a standing desk in my cube at work and a mechanical key keyboard, and you'll realize it's really a blessing when I work from home most of the time. All right, we're going to talk nerdy stuff for a bit. This is how this was built. There's really three main libraries. D3 is data-driven documents. It's a JavaScript library for making all kinds of data visualizations. It could be maps, it could be charts, it can be anything you can think of. It's kind of a combination of a DOM manipulation and a SVG and a data binding library. And it is really awesome. It's kind of hard. D3 is not hard like there's something wrong with it. Because it does so much and it doesn't abstract a whole lot from you, it's kind of hard. So if you just need to make a plain old bar chart, I probably wouldn't use D3. But making that kind of complex visualization on the map and on that chart, D3 was the best way to go. It's a really good library. Leaflet, I don't think needs any introduction. It's the most popular JavaScript mapping library for a reason. And Bootstrap is what we use for a lot of our sites. It's an HTML, CSS, and JavaScript library. It's mobile first for things like layout and responsive design and a lot of your common widgets. So when you resize, it will be responsive and change the header and put everything in a single column. So folks on phones can have fun too. It's 2015. If your site doesn't work in mobile, it really doesn't work anymore. So Bootstrap makes it really easy to get your site working in mobile. Try to do one totally irresponsible thing per project. And in this project, it was object.observe. That's a part of ECMAScript 7. And the only browser that supports it is Chrome. But there's a polyfill that works perfectly on all the old browsers. What object.observe does is it's data binding the way data binding should be. I'm going to have to walk over here and let's see. So there's I just called my JSON object I'm using here model because I'm boring. I can go model.object metric ID and see what my metric ID is. This is just a JSON object. If I change that to something else, everything in the dashboard changes. It automatically gets that change. I can look at, boy, I'm a good typer. Can't see what I'm typing until I turn around. These are all the currently selected neighborhoods. If I make a typo, somebody just yell. Let's see. I don't even know if there's a 2 neighborhood. Now we have that one neighborhood selected. So object.observe, a lot of the libraries, Angular and Ember and Backbone, the way they do data binding is getters and setters and timers, and it's really not very elegant. Object.observe is great. I mean, this is kind of spinner hat stuff, so this isn't your thing. Just go to your happy place for a minute. It's really, really cool. So I would check it out if you get a chance. Andy Osmani, one of the geniuses for front-end development at Google, wrote a really good article about it on HTML5 Rocks. All right, for the tools I use to build it, of course you need a text editor. The right text editor is any text editor you're productive with. I use Atom, which is an open source editor from GitHub. It's very good. It's kind of like Sublime Text. If Sublime Text development kept continuing, it kind of, at some point. Oh, thank you. There are a lot of tasks you have to do as a web developer. You have to pre-process if you're using less or Sass or Stylus, and minify and concatenate. Minify and concatenate your JavaScript and process your images. Set up a live reload server. You might be processing Markdown into HTML. A lot of tasks. So you really need a task runner to automate that. The big 2 are Grunt and Gulp. I use Gulp on this project. I tend to prefer it. But if you use any kind of task runner for your project, you're already solidly in the win column. CSS tools we use, I'm using Less for pre-processing for no particular reason, just because I use Node a lot, and Less is just really easy to use in Node. In linting, autoprefixer is an extension that will save you a lot of time. Normally, if you're just writing CSS by hand and you want to do something like a transition or even a box shadow, you have to go -moz -box shadow -ms -box shadow -webkit -box shadow. With autoprefixer, you tell it, hey, I'm supporting Internet Explorer 9 and above and the last 2 versions of every other browser. It will put those prefixes in for you. So you just write it once. It's a really, really handy thing. It's all automated. CSS minification, JavaScript tools, JSHint, don't tell Crawford. JSLint is good too, but it's mean. Concatenation and uglification to shrink the files down. The image tools, when I need to make images, I use Inkscape for vector and GIMP for raster, and imagemin is an automatic image minifier that shrinks things down. Now, the data for this project, there's no back-end server for almost any of this project. It's just HTML and JavaScript. The neighborhoods are done in TopoJSON, which if you're not familiar with, you're probably familiar with GeoJSON. TopoJSON is a different JSON format for geographic data. What it does, it's kind of like an old ArcInfo coverage. It stores coincident geometry once. So if 2 polygons share a common border, that border is stored one time. And that saves a lot of space over the wire. I think our shapefile for the neighborhoods is like 1.7 megs. Our TopoJSON file for that to go across the wire is a little under 100 kilobytes before it gets to gzip. So it's a really good format for sending polygon data, which is usually quite big, over the wire. All of our data is delivered to us in CSVs, and it's very simple. The TopoJSON has a neighborhood ID. CSV comes with one column as the neighborhood ID. The next column will be Y underscore and the year. So all that data comes in a way that's very easy for non-GIS people to get us that data. Because these things are decoupled, it's very easy to add additional years or different data sets as we go along. And this CSV is one of my Gulp tasks gets transformed into JSON. Architecture. This thing runs on my $5 a month Frappuccino server. I call it that because that's about how much it costs. I don't want to talk too much cloudy stuff, because whenever I hear the word cloud, I just throw up a little bit. There's actually a plugin for Chrome called Cloud to Butt Plus. It replaces anything you surf. If it says the cloud, it'll change it to my butt right in your browser. That's just free. It's not really hard to talk about. We try to architecture things now as simply as we possibly can. And this site is just HTML and JavaScript. You can put it anywhere and it'll just run. So I put it out on a $5 a month cloud server. It takes me about 60 seconds to make a server like this. I don't know how long your IT department takes, but ours takes longer than that. And because it's uses solid state storage, and because it was using Nginx, it had about a 900% performance increase over our many $1,000 local stuff, both hardware and virtualized. So I hate talking cloudy stuff too, but it's something to consider. Now, performance is very important. I mean, it's really easy to ignore performance because you're saying, serving up all these image tiles and all this vector data, so I'd be like polishing a turd if I worried a whole lot about performance on our websites. But performance is important, and this is the size of the first version of the dashboard. Over the wire is about 1.3 megabytes, which isn't bad. The average page size in 2015 is creeping up on 2 megabytes. So it's not great, and 3 seconds page load time is really not great. The new version is 328 kilobytes over the wire. It's about a quarter of the size, and it loads in a little bit over a second, a little bit more than 1/3 of the time of the original. So despite doing all this extra stuff the original version didn't get, it's become much smaller and much faster. So, some lessons learned from this project. Usually the hard way. I learned these lessons so you don't have to. First, a word on engineering, or as we usually do, over-engineering. A lot of you, don't raise your hand. A lot of you probably are using a 5-figure enterprise GIS server on a 5-figure enterprise piece of hardware that how you need to run this 5-figure enterprise server to serve base tiles. This is what I use. It's 1 kilobyte. It's just a simple node script. It's running on my Frappuccino server, and it's serving out all our base tiles. And in terms of performance and scalability, reliability, it will beat the snot out of your 5-figure enterprise GIS server. We tend to take our tool and use it to beat our problem instead of taking our problem and using it to pick our tools sometimes. Complexity kills in development. The more complex your solution, the slower, more expensive, the more resources it takes, the harder it is to change. So one thing we learned during this project is to make solutions only as complicated as they absolutely have to be. That makes it easier for us, it makes the system faster, it makes it easier for us to share this code so other folks can take advantage of it. The Shroot rule, basically, don't be dumb. And it's really good we heard this talk about design and making good design. Government people, I mean, except for everyone here, government people make some of the worst websites in the world. And I offer you as evidence almost every government website you've ever seen. And as a developer, you're kind of the last firewall in between your customers that are making what you know is a turd, and your citizens are going to have to use that. So learn how to say no. I've had to say no on the dashboard project so many times that they call me Mr. No. But it's one of the hardest things you have to do as a developer, but you really have to do it to make sure the product gets out the door is the best you can make it for your citizens. We like to say GIS is special, spatial is special. Some of our GIS is so special, we put a P after it, and that's fine. That's all done with the best of intentions. And we say stuff like that, we're thinking of pictures like this. We just have to make sure it doesn't become something like this. Spatial is special, but all the tools I talked about using to build this are the exact same tools I'd use to build anything, whether there's a map in it or not. And we have to be careful that spatial is special as the icing on the cake, and isn't a wall we put up between ourselves and other folks. So you're in a coffee shop and you see that person with a MacBook and skinny jeans and a non-functional scarf, go talk to them. They'll have a lot of interesting things to say about your project. And finally, open source all the things. Really think about open sourcing your code. It's probably been one of the most amazing and fulfilling decisions I made in my entire career, was to start open sourcing our code. Besides being fun, helping people and meeting new people, you meet a whole new community. Developers there's an artistic aspect to it, and like a writer wants to be read and a painter wants their work seen, a developer wants their code to be used. So to do that, the best and easiest way to do it is open source your code. I find the biggest thing that holds people back from this is they don't think their code is very good. And I tell you, no one's code is worse than mine. And I've never had a bad experience open sourcing code. No matter what level you're at, there are people that will learn a whole lot from you. And there are people that are ahead of you that will teach you a whole lot when they see your code and tell you how you can make it better. So that's my talk. This is the GitHub repository, blog, Twitter, email address. Ask me anything, and if you don't want to talk in front of this group of weirdos, just send me an email later, and I'll be happy to answer any questions you have.